All right. So yeah, the question about assignment 1, do we just fill in the gaps? Effectively, yes. It's like I gave you like a starting point, and then you just go on and put in what you got to put. And of course, there's the Python version of the code that was provided that you can use as a basis as well. Any other questions before jumping into where we left off last time? All right. Well, if you have any, just type them in the chat. I can hear you. In fact, let me just turn up the volume to make sure I can hear you well. I didn't see the notification that session is being recorded. Can you double check? I don't record on Collaborate. I record in Open Broadcast Soft, whatever the S stands for. And the reason I do that is it actually records at a much higher quality. So yeah, OBS. I do that because it records at a much higher quality, where if I just record over Blackboard Collaborate, like the quality is like basically the same as the stream. It's not very good. But with OBS, I can record in HD. Now, my computer doesn't have the gusto to to do 1080, but I'll do 720. Are we supposed to be using an online client for C++? No, you're supposed to be using Visual Studio. But of course, you can use any IDE as outlined in the outline or in the first set of slides. But the rule is, technically, officially, we're just using Visual Studio. I recommend Visual Studio. It's much better than the alternatives if you can use it. And then why do they have plastic stairs in residence when it's winter? Just fell down them. Well, I don't have an answer for you for that, but I'm really sorry to hear that you fell. Hopefully it wasn't too bad. Hopefully you didn't hurt yourself too much. Okay. Can we get an F in the chat from my boy Felix? Okay, sure. Everyone, there you go. All right. Okay. So now time to actually get to, okay, good job, everybody. Time to get to the actual lecture. Okie dokie. Last time, this is basically where we stopped off. It was, well, here, let me go back a slide. So we were looking at the while loops. We have a counter. It's very similar with C++. The only difference is squiggles with the way the print's done. I guess C++ was new, like the plus operation. And we need to put the condition in parentheses. And then, of course, we can do the same thing with just like the condition itself. Of course, C less than 5 is an operation that will result in a Boolean, where in this example, this is just the Boolean. So, I mean, it's effectively the same idea. I'm just showing you another example. Okay, in strings, with strings. In Python, we could index strings. We have the string, a string. It's hello. And I could say, well, give me the letter at location 1. And of course, all of you know that the letter in index 1 is, of course, E, because H is 0. Remember that. And then in C++, here's the same thing. We need from the standard library, we need the string. I call it a string. I called it hello. And I'm going to print out a string at 1. And of course, this is all, it's going to be E. Both these languages are 0-based indexed. Now you might remember in Python, we can do this, which would give you like the last. It would count backwards. So this would actually give you the letter O. You can't do this in C++. This is not an option. This is no good. I mean, in one of the labs, I think it might be this week's lab, if not next week's lab. We'll see a bit of an example of where we can kind of do this, but it's not going to do what you want it to do. Okay. For each loops, you may remember these. This is like for each thing in a collection of things. So in Python, we've got the string hello. And all right, so for each thing in the collection of things, well, a string is a string. So C is going to be a character. And print out the character. So that would result in HELLO. In C++, here it is. The only real difference from anything we've seen before is just this here. The format, instead of like for C in a string, we say for. Now, we need to specify what the type is because we're creating like that variable C. So for each character C, and then instead of saying in, we put a colon. That's it. and then the name of the collection of things that we're looking at. So in this case, of course, a string is a string. C is going to be the type of things that are in this collection, which are, of course, characters. So for each character in a string, print out the character. That's all. Did I hear any boops? Nope. Okay. Python, here's a list in Python. I can say for each thing in a list. So in this case, thing is going to be the integers, 44, then 23, then 55, then 11. And it's just going to print these out. In C++, here we go. We're creating an array. Note that if you're expecting C++ arrays to act like Python lists, you're going to be really disappointed. They are much simpler. We're going to talk a lot about arrays very, very shortly, but here's a quick and dirty way of creating an integer array. So it's int, an array, and then we've got these square brackets to say like, okay, so it's an integer array. And then in these squiggles, I've got whatever they are and semicolon. And then it's the same as the previous slide. For each thing in that, the only difference is, of course, the type is integer now because the things inside this collection of things, this array, they're integers. Yes. So this is like a simple counting for loop, which you may remember is effectively actually doing the exact same thing as the for each loop, but for each I in the range up to, but excluding 10, print out I. So this would say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all on a new line. Now here's how we do it in C++. This type of loop right here might be the most common loop you write. So get used to this. It's not as natural to read as like Python's, for example, but here's what this means. One, this is just going to count from 0 to 9 inclusively, or 10 exclusively. And we just have the print. But what is going on here? So this says for integer I starting at 0. And then the thing in the middle is the condition. And the condition needs to evaluate to a Boolean that's either going to be true or false. This means we can actually get quite clever in what we put in here. But in this case, is I less than 10? Well, the first time through the loop, I is 0. And then what happens after we finish the loop? Well, we see I plus plus. This means add 1 to whatever I is. So in this case, the first time through the loop, I is 0. Is 0 less than 10? Yes, true. Print it out. And then we say I plus plus. Well, I now becomes 1. And then I ask the question, is I, which is 1, less than 10? Of course it is. And so on and so on and so on. Pretty different, but they're awesome. You're going to be using these a lot. Yeah, technically you can do, and this is a really weird contrived example. Don't get me wrong. This is silly. Don't do it this way. But the condition in the middle can be whatever we want. We can say like, well, I is less than, what is this, 100,000, or I divided by 22 is, or I mod 22 is 0. So if the number is less than 100,000, or the number happens to be evenly divisible by 22. Why? Because I just made this up. And then what are we doing at the end here? Well, I'm actually counting by 81s. I equals I plus 81. I could have wrote I plus equals 81 to do the same thing, but so the first time through the loop, I is 17. Then the next time we add 81, then we add 81, and so on and so on and so on. It's a pretty silly example, but we can get as creative as we want with these. I don't know if I've ever really written a for loop like this before with really weird conditions in the middle. Not weird, but more complex conditions in the middle. That doesn't mean you can't. That doesn't mean you shouldn't. I just haven't. Counting for loops with indexing. Whoops. So of course, a list. We've got this list. I think it's the same list as before, and I get the length of a list. So I know, okay, 1, 2, 3, 4. The length is 4. Great. Then I say for I in the range length of the list, print out a list at index I. So the first time through the list, I is 0, then 1, then 2, and then 3. The first time through the loop, a list at 0, well, that's 44. A list at 1, that's 23. A list at 2, 55. A list at 3, 11. And of course, remember, although the length was 4, and we say range 4, that'll only give us 0, 1, 2, 3. It'll never get us to the actual 4 because there is no such thing as a list at index 4 because that doesn't exist. C++, here we go. I mean, it looked very, very similar. In fact, based on everything we've seen so far, this should be like, yeah, like if I quizzed you on how to do this, you probably would have been able to get this done. But there is a bit of a catch. You might see that in this case, I asked the list, hey, how big are you? Tell me how big you are, right? And the list knows that it's length 4. In C++, our arrays, they're too stupid to know how long they are. If you wanted to ask the array, hey, how long are you? I got bad news, you can't. That's not a thing you can do. We have to know how big this array is. So it's like hard-coded. Not a big deal if we have a hard-coded list here and we always know, well, it's always going to be 4 because these numbers are in there. But I'm imagining you can see this could become a problem if we don't know how long some arbitrary array is. More on that a little later. Yeah, okay. Practice. The only way you're going to get good at this is to practice. I know I sound like a broken record. I said this last semester, but honestly, the only way you're going to get good at this is practice. If you finish last semester strong and you don't practice the transition from like Python to C++, you're going to be off to a bad start. So don't think just because you crushed 161 that you are in great shape day 1 of 162. Don't get me wrong, you are very well prepared. If you did very well in 161, chances are you're very well prepared for 162, but you still got to make sure you get that transition, because if you can't get the C++, you're not gonna be able to do the rest of the course. Practice. People who fail the class, yeah, usually that's what it is. Go practice. Where to practice, wherever you want. Use Caddis, like we did in the labs last week. Start with the early easy ones, work your way up. If you get stuck because you don't know how to do something in C++, I've got good news for you. And this is a hyperlink, and if you can see this, which you probably can't, it's a link to Google. So if you're ever stuck, just going like, how do I do a for loop in C++? And then there you go. And like people, like I do this because I only use C++ like once a year when I teach 162. So every time I have to remember like, wait, so how do I do arrays in C++? I go to Google and refresh. So I'm not giving you bad advice. I'm giving you the advice that I literally do when I need to relearn C++. Okay, cool. Are there any questions about any of that we've seen so far? So if we need the length of an array, we will need to use a counter. Well, how are we going to use a counter? Like, how? I'm not sure how we could use a counter, because majoring in Stack Overflow. Yeah, no kidding. See, we can't use a counter because, like, what are we counting? Because if we're counting, like, you might say, well, put in a loop. Time to make our own list object. I got a spoiler. You're going to do that. We're going to start with simpler ones. We're going to start with stacks and queues, but we will work our way up to lists. But yeah, the counter is going to be problematic because you might say, well, I'll read in a loop. People will keep entering numbers into a loop, but where are you going to put those numbers? In an array? Well, how big does that array need to be? Well, you don't know because we didn't do the count yet. We've kind of got like a chicken and an egg situation. But we'll see solutions to this problem. Okay. All right, pointers. So is this lecture 2? Let me just verify. Yes, it is. Okay, so here is a topic that people think is challenging, but it's not. That doesn't mean you're going to pick it up like that, of course. It's not trivial to figure out, but people tend to get really worked up about pointers when I don't know. I think it's like it's just people are giving bad advice to other people. They're not overly challenging. It's a little weird. It's a little different, but it's not overly challenging. In fact, it's not even that different for you because in Python, anything that's like not a primitive type is technically a pointer. So you might remember last semester I was saying, oh, is this a list? And the answer was no, it's a pointer to a list, right? So pointers, it's going to seem weird, but if you follow the rules, and the rules are very simple, the rules are not going to change from anything we've seen already in the course. But I'm just going to show you new things that follow the same rules. Long story short, I'm getting ahead of myself. The point of this is we're going to learn about pointers. We're going to learn how they're really cool. And hopefully we see that they're not as scary as people think. Because I'm willing to bet people in this class who have heard about C, C++, have heard things like, oh, pointers, oh, those are the worst. When it's not. In fact, it's kind of neat. So the point of this lecture, see how pointers work, see how useful they are, see how you can mess things up with them. Yeah. All right, pointers. So variables we make in our program go into memory, like RAM, okay? So if I say int, an int equals 5, so here I'm declaring and assigning the value to a variable in one line. The code makes a variable called an int and assigns it the value 5. The value 5 is stored in RAM somewhere. I don't know where it is, but it's in there somewhere. And we use the label an int to access it. So imagine for a second, this code runs. And the computer, for whatever reason, it decides, because the computer decides where it's going to put these things in RAM. So the computer's going to go, oh, okay, I need to make an integer variable called an int and put the number 5 in it. Okay, I'm going to go to memory address 1,032,032 and put 5 in there. So now an int, when the programmer uses an int, I know it like gets us to memory address 1,032,032. Is that? I think that's what I said. So an int is just like, it gets us that 5 because in that memory address is the value 5. Generally, where in RAM the value is stored is up to the operating systems. Unlike Python, C++ actually allows us to ask where in RAM the value is stored. So in Python, like, you could technically do this in Python. Don't get me wrong, you could do this. But in C++, it lets us do this, and it lets us use this information cleverly. So, oh, okay. Warning, there's going to be new syntax I'm throwing at you. It sucks, it's weird, and a lot of the syntax I'm about to show you is very context sensitive. Depending on how you use the syntax in certain contexts, it means completely different things. I'll point these out once we get there. So a pointer. This ampersand, it's a special operator that tells asks the computer to tell me what the address of something is. So the simple ampersand is going to be used a lot, like I said, but it's context sensitive. Okay. When we have an assigned variable, we can throw an ampersand in front to get the memory address of where it's stored. So I'll show you an example here. An int equals 5. So nothing new, right? The computer goes, okay, I'm going to find memory address X, put the value 5 in it. So when I print out an int, well, that's just going to be 5, is at, and then I say an int, but I put this ampersand in front. This doesn't say, give me the value of an int. It means, what is the memory address of where an int is? So it actually will tell you the memory address of an int. So let's say I run this, okay? 5 is at 006FFDC0. Okay, great. So the value 5 is located at that memory address. But every time you run this, expect to see different memory locations. I'm going to show you this in practice. First build always is slow, apparently. Just check if there are any questions. Nope. Okay. Okay. Oh. Can you use a plus sign instead of as if concatenating? Maybe concatenating strings in C++. Honestly, I don't remember. You know what I would do? And here, how about you do this? Google that. And then you'd come back with the answer, because honestly, The way I would answer that question, if you asked me like at office hours, is I would Google it because I don't remember. Okay, so let's control 5. Is it not gonna? What's going on here? All right. 5 is at 00D3FA80. Great. So this time when I ran it, it stored it at that memory address. Let's run it again. See if it gives us a different one. Look, it's a different one. It's a different one. But long story short here is an int has the value 5, but then when I put the ampersand in front, it's not saying, it doesn't say give me what the value is. It says, well, where is it? Tell me the memory address of where it is. That's what it means. Yeah, okay. Yeah, there you go. Now, I'm not going to rush through this because it can be weird to wrap your head around at first, but hopefully you have that click moment of, oh wait, no, it's just, there's this new rule we can do, and if we follow all the rules we know so far with this new information, everything will be fine. But I will go slow, type in the chat, slow me down, ask questions if you get a hiccup at any point. Let's not break the awesome trend of really good questions and discussion taking place in the chat today. We need this. Okay, so pointer variable. So instead of simply printing the memory address out, we can save it. Because, I mean, just printing out where it is not overly useful. We can save it as a variable. But the memory address, although, like, clearly it looks like an integer, or at the very least, like, okay, it's got F's and D's and C's and whatnot in it. So this is a hexadecimal number, meaning it's base 16. If you don't really know what that is, it doesn't matter too much right now. But like, clearly it looks like an integer, like it's a number, but really it's not a number. It's a pointer, right? So really the type, because you remember, C++ is really picky about types. You got to say, I made an int. It's an integer. C++ is happy. If I want to store the memory address in a variable, I have to create a variable of the appropriate type. So in this example, I'm saying int myvar, just a new variable name, equals 25. So this all checks out. MyVar, it's going to store the value 25, and it's an integer. Everything's happy. Now, here, we've got something a little funny. It says int star foo equals ampersand myvar. Let's unpack this. So hopefully the top one makes sense, because int myvar 25. Great, we made a variable, it's an integer, we have to be specific because it's C++, and it's got the value 25, great. Okay. I want to store a pointer to an integer. So that's the type. And the way to modify the type is to put the little asterisk, the little star. So when I say int star, it doesn't mean that the variable is going to hold on to an integer. It means it's going to hold on to a pointer to an integer. I hear the boops. I'll get to them in a sec. I'll just finish this up. So int star, foo isn't an integer. Foo is going to be a pointer to an integer. Now, what am I actually assigning to it though? So I've declared it, but what am I assigning? Well, I say myvar, which is 25, but we see the ampersand. We actually don't care about what the value inside the variable is here on that line of code. We're asking C++, where is it? What's the memory address of myvar? So foo is a variable that will not hold an int, but a pointer to an int. Now I heard some boops. What do we got here? Okay. Star means it's saving it in hex. No, it did not. Yeah. Absolutely. So look at this. Look at this. What a beautiful use of the chat, everybody. Someone asks a question, other people ask, there's some discussion. Amazing. So int means myvar is an integer. Int star means it's a pointer to an integer. Now let me ask you, I mean, you don't have to type this in the chat. You could just like answer it in your head. What do you think I would type if I wanted a pointer to a Boolean? If you're thinking bool star, you're right. That's it. So if I go here, let's just, in Visual Studio will actually be really helpful. So if I say int the equals, it's happy. But of course, this isn't really what I'm looking for here. It sounds like foo would be good if we can simply be declaring when something is supposed to be a pointer or not. Yes, that's effectively it. It's like, we want to specify, wait, do we want an integer or do we want a pointer to an integer? Do we want a string or do we want a pointer to a string? Do we want an array or do we want a pointer to an array? Which is weird because you might remember in Python, whenever we had lists, any variable it had to be like a pointer to that list. In C++, when we use like arrays, or eventually when we make lists, we have a choice. Do we want the variable to be a pointer to where that list is? Or do we want it to be the start of that list? This will become much more clear once we actually use this and get our hands dirty a bit, but yeah. So here, everything's happy. Did I hear another boop? No. So here's everything's happy because, well, int, this is an integer variable and int is an integer. But as soon as I say this now is saying, a value type int star cannot be used to initialize an entry of type int. It's angry because it's saying like, well, hold on. This is like, you're getting me the memory address of an int. And the memory address of an int is, of course, an integer pointer, right? Like, that's what it is. And I'm trying to store an integer pointer into this integer variable. No good. We need to put the star. And as soon as we put that star, it's happy. Because the adder, it's a variable of type integer pointer. Not an integer, a pointer to an integer. And this right here is a way to take a variable and get its memory address, get the pointer to wherever that thing is. Now, remember how I was saying we're going to see some symbols that have they're context sensitive. So of course we've used star before. We've used star to mean like multiplication. Now, when you add the star to your type, it modifies like the type. It means like, no, it's not an integer, it's an integer pointer. Now here's a funny I heard a boop, so I'll just check on that. So it's a new type of variable and not a modification to existing variable type. So you're right. It's like a whole new type. It's not an integer, it's an integer pointer, and it's its own unique type. Now, they've got something in common. It's that like at the end of the day, they're both dealing with integers, but it is like a different type. It's a different thing. So yes, you're right. You've got your head on straight, so that's good. Okay, so this right here is, of course, an integer pointer. What do you think this is? Now, this is not a trick question. It's what does this asterisk mean? What do they mean in this context? So in this case, this means this is an integer pointer. So this is something that will point to something that points to an integer. Weird, you can do it. Doesn't mean I should have in this case, but you can do this. The value instead of the address. The value instead of the address? I'm not sure what the question is. Are you asking like, well, what if you have the address and how do you get the value out of the address? If that's the question, we'll get to that in a moment. But in this case, if you're thinking, oh, are we getting the value by having two stars? No, we're actually moving like a step further away. We've got a pointer to an integer. Why? Because. All right, yeah, so foo is a variable that will not hold an int, but a pointer to an integer. Okay, so now just a couple of examples. Everything's happy here. Int my var is 25. Why? Well, because 25 is in fact an integer, and we made an integer variable called my var, and we put the 25 in it. Okay, good. This, same as before, we've got an integer pointer, we're calling it foo, and we're putting the memory address of wherever my var is. Like, so wherever the value 25 is stored in the variable my var, well, where is that in RAM? And then down here I've got bar, which is, I'm just assigning to be my var. So that's simply just 25, right? So what's in each of these variables? Okay, so let's think about this. My var, it happens to be in 1776. Why? Because. That's memory address 1776 because. If I ask ampersand my var, it gives us 1776. If I just say, well, what's bar? Well, it's just the copy of 25. You might remember, well, no, we'll get more to like copy and reference in a moment. So assuming 25 is actually stored in memory address 1776, of course. Pointers. So we just saw two new uses of the symbol star and ampersand. So we know we can use ampersand for and we know we can use it on a variable to say, well, where is this variable stored? And star or asterisk, we know we can use that for multiplication, and we know we can add it to like the type to make like new types. So each of these has two uses already, but they're context sensitive. So unfortunately, or for better or worse, we're going to be using these symbols a little more in different contexts to mean different things. I think this is where people get frustrated with pointers. They get lost in the syntax. They don't get lost in the ideas, but the syntax. So the best way to get this is practice, of course. But let's see. So, and even more later. Yeah, okay. So dereference. So I kind of hinted earlier if someone was asking the question about what are the value and how do we get the value from the address? Like what if I have the memory address of my var, but for some reason I lost access to like the variable's name. You know what? This is best explained with an example. So what if we have a pointer variable and we don't want to just print out the memory address, but what's actually in it? So if we go back here, in this case, let me go back a little more. In this case, I put the ampersand here to say, well, my var, don't tell me what my var is, tell me the address of my var. So now we want to do the opposite. What if I have the address of my var and I want to get the value out of it? Like what's actually stored at that location? Maybe some detailed indexing using RAM, I'm not sure. What would be a potential use of knowing the memory location? Oh, there's a bunch. And we're gonna see, okay, optimization is one of them. It's gonna be really handy when we start dealing with pointers. And see, the reality is too, everything you're used to in Python is it's all pointers. So everything you have is actually like a pointer to the start of your lists. So we're going to be using pointers a lot, and the more we use them, the more uses we'll kind of see for them. And at the end of the day, it's like more flexibility. But there's also like you could also get weird about funny indexing in RAM, like Duncan had said. In fact, one of the labs is doing that, and I'm actually having you like really mess up your computer's RAM intentionally, like by breaking some rules. But don't worry, you won't actually break your computer or anything. Or at least the likelihood of you breaking is like 1 in 50 billion. But anyways. Okay. Yeah. Okay. So we know ampersand in front of my var will tell me 1776. But what if I have 1776? And I want to say like, well, what's in 1776? That's what we're looking for right now. Well, here we go. Another use of star. So let's look at what's going on here. We've got my var is 25. Great. Foo is a pointer to my var. So in foo, I've got 1776 because foo, that is the memory address of where 25 is stored. It just happened to be a memory address 1776. My var, bar, well, okay, I guess bar just has that. That's what we saw before. And then all of a sudden I'm saying baz equals star foo. So now when we use star alone and in front of foo, not on the type, but in front of the variable, we get the memory, or we get what's in that memory address. This is called dereferencing. So in this case, it's saying, okay, store in baz whatever's in the memory location that's in foo. So foo stores 1776. Oh, okay, so we'll go to 1776, but what's in 1776? Ah, the value 25. And we put that into baz. That's how it works. So we see another use of the star. But of course, in this case, it's not multiplication. It's not make a type of like a pointer type. It is don't tell me the memory address, tell me what's in that memory address. Now, of course, you could only, like, this will only work if the variable that we're trying to use is a pointer. Let me show you. Wait, whoa, what happened here? I'm just gonna copy this. So this will work because foo is a pointer, right? So I can access that. But like what's gonna happen if I say, like, I don't know, int like, this doesn't make any sense because my var is an integer. It's not a pointer. So I can't ask the integer, oh, what's in your memory address? Because that integer, it's not a memory address. You can't do it. That question doesn't make sense. It doesn't compute. Because I cannot say what is, like, my var is an integer. And then I'm now asking, hey, my var, what's in the memory address you're storing? That doesn't make any sense because my var isn't storing a memory address. Foo is, because it's a pointer. Int star, it's a pointer. It's great. So we can do this. This is why it's happy. Now, what happens if I do this, I wonder? Because think for a second, what is foo star? Well, that was the value 25, right? And then we store 25 into baz. Why is it 25? Well, let's make sure this makes sense. 25 is my var. I get the memory address of my var, which we were saying is 1776. So foo holds on to the memory address 1776. And then down here I say, okay, 1776. Oh, no. Get me what's in 1776 because we have the star, which is, of course, 25. And then we put that into baz. What do you think's going to happen if I do this? Well, it's not going to work. Why? Well, because I'm saying, like, all of this right here is just the integer 25. I cannot ask an integer what's in your memory address, because that integer goes like, but I'm not a memory address. I'm just the number 25. I can't tell you where that is. So this doesn't make any sense in this context. Anyways, just check for questions. Now that has to point to the values. Okay. Okay. Yeah, all right. Different. These symbols are context sensitive. In declaration, it's a pointer. When the variable's used, when using a variable, it's dereference. So this is creating the pointer. This is like dereferencing it. Don't tell me what's in the don't tell me the reference. Tell me what's like in it. All right. Address of and dereference. So these operators are complementary. They like undo each other. If I say ampersand var name, that's the address of where var name is. And like we read it as address of var name. That's the trick. That's how you'll never forget, right? Address of var name. Star var name, well, that's a dereference. That can be read as like, well, what's the value pointed to by that variable? So in this case here, in this case here, this assumes that var name is a pointer because we're dereferencing it. Because if it's not a pointer, if it's like an integer, we can't dereference it like we just saw. You can't dereference a boring old, plain old integer. You can only dereference things like a pointer to an integer or a pointer to an integer. So they can undo each other. Here's a quick quiz. What's going to be printed out by this? Someone type in the chat. Let's see who wins. Oh, I guess I should actually show you the slides. 25, absolutely. Why? Well, because we've got my var, which is 25. And then they were saying, oh, no, don't give me the value. Tell me where 25 is. And then we put the star in front of it and we go, oh, no, don't tell me where it is. Tell me what's in it. Or we can read it kind of like the other way. The value pointed to by the memory address of the variable 25, or the variable my var, which holds 25, is just 25. We just undid each other. we got the address and then we dereferenced it, the address. So we went from the value to the address back to where that points us to, so the value. What's printed out here? 25. Yeah. Okay. Another question. So you would receive an error if you put star myvar. Yes, because myvar is not a pointer. It is just, in this example, an integer. So you're absolutely correct. This only worked because we got the address first and then dereferenced. Now in practice, of course, this is silly. So here's a test. Here's a test. And now just answer in your head, and you'll know if you're right or wrong. But what's printed out by this? Well, this one's the easy one. What's printed out? Well, myvar, which is 25, so we should see 25. What's printed out by this? Well, we're saying, well, what is foo? Well, foo is a pointer to wherever myvar is. And now we see the star in front of the variable name, which means dereference. So although foo is an integer pointer, I don't want the pointer because I put the star in front of it. That means tell me what's at that memory address. So in this case, it would be 25. Now, what would be printed out here? Well, this is just, let's use this example we were using before. It would be like 1776, right? Why? Because we're just pretending that just happens to be where our computer decided to put that variable in RAM. What would be printed out here? Well, it's the same thing. Whoop. Wouldn't the value of foo be printed? In this case, both of these, yes. Foo, did seeing that next point answer your question, Dominic? Yep, okie dokie, yeah. So what he was asking was like, well, hold on, wouldn't that be the value of foo? And yes. Ampersand myvar and foo would be exactly the same. Every time we run this code, they'll be the same as each other. Now, between runs, they might have different values, but every time they run, they're gonna be the same. Okay. Well, we actually just established this. This, of course, would be true because they are the same. So look at that, Dominic. You beat me to the punch. Look at that. Now, what's going on here? Here's the real test. What do we think? False? Well, I don't know. Let's look at this. So foo star would be, okay, not the memory address. So it wouldn't be 1776, it would be 25, right? What? So this would be 25. And I'm asking, is 25 equal to, okay, well, my var is 25. What's the memory address of it? 1776. Then what's inside of it? 25. What's the memory address of that? 1776. Then what's inside of it? 25. So it would be true because we have 25 equals 25. To be clear, this is rather silly. You wouldn't do this. This is useless. I'm like adding one, subtracting one, adding one, subtracting one. I'm just doing something, then immediately undoing it. 25 is 25, yeah. So the answer is true, or as Thomas said, it would be 1 because, of course, 0 is false, and anything that's not 0 is true. So there you go. Now, what about this one? I think all we have to do is just check what they're ending in. If they end in stars, we know they're going to be equivalent. Anyways, okay. So, what's going to happen with this code? This is valid code, but what does it mean? What's printed out here? Whoop. Look at this code. Like here's a little quiz, and then we'll run it and see what happens. What's going on here? Brain has short-circuited. Yeah, getting to that time. So what's going on? I think you might be right. So what we're saying is, okay, 25, my var, great. Now, take the memory address of that and store it in foo. So let's say it's 1776. Then I'm saying, oh, memory address 1776, inside of it, assign the value 35. So let's just copy and paste this code just to make sure we're not crazy. So if we run this, I'm thinking what's going to happen is, okay, 25 is in my var. I get the memory address of my var, put it into foo, and then I say foo, but dereference it and say inside of foo, put 35. And of course, foo, and like star foo and my var are like getting us to, like, it's the same chunk of RAM. So if I take that chunk of RAM that my var has and put in 35, I should see 35. Let's see. 35. If you're scratching your head, slow down. Nothing that we just did is breaking any rules. It's just here. Imagine for a second, I have a box. And I have another box. And then here I've got my var. Okay, well that's impossibly small to read. Sure. And then this is foo. I think I have cap lock. Yeah, I do. And this happens to be memory address 1776. And this is memory address, I don't know. It doesn't matter. But inside of here, I have 1776. Actually, here, I'll make this like a green. 1776. So effectively, we have like an arrow to here. This is really small to see again as well. Hopefully you can kind of see on Colab. So we've got this arrow, and inside of that I have the value 25. So I'm saying my var is 25, great. Int star foo equals memory address of this. Okay, perfect. I put 1776 in there. And then I say, okay, dereference foo, which means, okay, well, foo is this memory address. And then I put the star, which means like, okay, well, what's inside? Which is the 35. And I'm saying basically inside this box, I want to actually put how do I crop? Geesh, I'm really bad at Microsoft Paint apparently. Select. I'm now saying, okay, actually inside the memory address of whatever foo is pointing to, 1776, put the value 35. And then later when I'm saying print out my var, well, what's in my var? Well, it's 35. If you're scratching your head, just slow it down. Because at the end of the day, it's following all the rules we've seen so far. We'll end here and we'll pick up back here as review on Friday, I suppose. I don't quite remember what this week's lab is, and it might be the case that this week's lab is unfortunately slightly ahead. In fact, here, let me just check. Because this will be a problem if I didn't get as far as I needed to get for this lab to make sense. Please be not what I think it is. Okay, no, we're safe. We're good. Oh, thank goodness. This next lab is okay. Okay, cool. All right, so perfect. Okay, you're changing the value that the point, yeah, okay. One of the questions is almost exactly like the one you just did, I believe. Good. Wonderful. So here, we'll wrap up here. Good job again, everyone, today. Keep using that chat. And otherwise, I'll see half of you on Thursday, and I'll see all of you on Friday. Have a great rest of your day. And for those of you that are coming to 215 tonight, I'll see you there.